this is Kalpana here. In this video, we are going to solve a differential equation using solvable for y method. So let's get started. Problem. Solve xp square minus 2yp plus x equals to 0. Solution. Given differential equation xp square minus 2yp plus x equals to 0. Okay, consider it as equation 1. Okay, we need to change in y equals to some function of x and p form, right? We need to change this equation, that is the given equation, in this form. But in order to reduce the complexity, see what we'll get. Xp square plus x equals to minus 2yp, that is plus 2yp. Okay, it goes to RHS, then it becomes plus 2yp. Then 2yp equals to xp square plus x. Then y equals to xp square plus x by 2p. You can differentiate this with respect to x, or you can directly differentiate the given differential equation with respect to x, and later we can change y by this. Okay, we can simply replace y by xp square plus x by 2p. Okay, this is equation 1, and from this we have y equals to xp square plus x by 2p. This simply, in order to reduce the complexity, we'll use this later. Okay. Now differentiate the given differential equation with respect to x. Then d by dx of xp square minus d by dx of 2yp plus d by dx of x equals to 0. We know that uv whole dash equals to u dash v plus v dash u. Okay. So using this formula, we can find the derivative of the first two terms. Okay. That is d by dx of x into p square plus d by dx of p square into x minus 2 into d by dx of y into p plus derivative of p, that is d by dx of p into y plus derivative of x with respect to x equals to 0. Then derivative of x with respect to x, that is dx by dx into p square plus derivative of p square with respect to x is 2p into inner derivative dp by dx into x minus 2 into derivative of y with respect to x, dy by dx into p plus derivative of p with respect to x is dp by dx into y plus dx by dx is 1 equals to 0. Okay, this becomes dx by dx is 1. 1 into p square is p square plus 2p, that is 2p into x is 2xp into dp by dx minus 2p dy by dx minus into plus minus 2 into y into dp by dx plus 1 equals to 0. Okay. Now put dy by dx equals to p. Then the above equation becomes p square plus 2xp into dp by dx minus 2p into p minus 2y into dp by dx plus 1 equals to 0. Then p square minus 2p into p is 2p square, okay, plus 1 plus the terms containing dp by dx. 2xp into dp by dx minus 2y into dp by dx equals to 0. Then p square minus 2p square is minus p square plus 1 plus here in the from the last two terms you have 2 and dp by dx common, right? So take 2 and dp by dx common from the last two terms, then you will get 2 times x p minus y. Then you can write minus p square plus 1 as 1 minus p square plus 2 times xp minus, now we'll eliminate y by replacing y by 2, sorry, xp square plus x by 2p. Replace y by this xp square plus x by 2p into dp by dx equals to 0. Then 1 minus p square plus 2 times xp, okay, xp minus, see you're having x in both the terms, right? So let's take x common from these two terms. You'll get x times p square plus 1 by 2p into dp by dx equals to 0. Then 1 minus p square plus 2 into, you're having x in both the terms, right? Again take x common from these two terms. You'll get 2x times p minus p square plus 1 by 2p into dp by dx equals to 0. Then 1 minus p square plus 2x into, take LCM, the numerator will get 2p square minus p square minus into plus minus 1 into dp by dx equals to 0. Then 1 minus p square plus 2x into 2p square minus p square is p square minus 1 by 2p into dp by dx equals to 0. Okay? So you are having 1 minus p square in the first term and p square minus 1 in the second term. Either change these two in the form of 1 minus p square or p square minus 1. It's up to you. Okay. So what I'm going to do is, I'll simply change in 1 minus p square form. For that purpose, we need to take minus common from these two terms. Then 1 minus p square plus 2x into, we'll take minus 1 common. Okay. Or minus common simply. You can write it as minus 1. Okay. So minus 1 into 1 minus p square. Minus 1 into 1 is minus 1. Minus into minus plus p square. Right? The same thing. You'll get the same thing. By 2p. Okay. Then this becomes 1 minus p square plus into minus, minus, cancel 2, you'll get x times 1 minus p square by p into dp by dx equals to 0. Again, you're having 1 minus p square in both the terms. So let's take 1 minus p square common from these two terms. Then you'll get 1 minus p square times 1 minus x by p into dp by dx equals to 0. Okay. So from this we'll get 1 minus p square equals to 0 and 1 minus x by p into dp by dx equals to 0. Okay, here it does not contain any dp by dx, so definitely it will give a singular solution. Okay. We are going to find solution for these two equations, solutions for these two equations. So let's consider the first one. 1 minus p square equals to 0. Then 1 equals to p square. That is p square equals to 1. Okay. What we'll do is we'll simply substitute p square equals to 1 in equation 1. So let's consider the equation 1. Xp square minus 2yp plus x equals to 0. You can write this as xp square plus x equals to 2yp. You're having p square, right? We can substitute p square value, not p. So what we'll do is, here you're having p, right? We'll convert it to square by squaring on both sides. Xp square plus x whole square equals to 2yp whole square. Then xp square plus x whole square equals to 2 square is 4, y square into p square, right? Now it's easy to substitute p square equals to 1. Okay, we can substitute p square equals to 1 in both the terms. Then you'll get x into p square, that is 1, plus x whole square equals to 4 into y square into p square is 1. From this you'll get x plus x whole square equals to 4y square. Then x plus x, that is 2x whole square equals to 4y square. 2 square 4, x square equals to 4y square. Then x square equals to 4y square by 4. Cancel 4. You'll get x square equals to y square. So here the solution does not contain any c, right? And is not obtained from general solution. So this is called singular solution, which is a singular solution. Okay. So we have two solutions for this. Sorry, We got two equations from this equation, that is 1 minus p squared equals to 0 and 1 minus x by p into dp by dx equals to 0. The first one gives singular solution. Now we'll check for the second one. Which is singular solution since it does not contain c. Okay. Fine. Now consider the second equation, that is 1 minus x by p into dp by dx equals to 0. You can write this as 1 equals to x by p into dp by dx. Here we'll write all the functions of x and differential dx in one side and all the functions of p and differential p on the other side. Okay. So you're having dp in the numerator of RHS. So we'll take all functions of p in RHS and we'll bring all the functions of x and differential dx in the LHS. So we need to take this x to LHS, right? So x becomes 1 by x in LHS into differential dx equals to 1 by p into dp. Here the variables are separable. Since the variables are separable, we can perform integration. Integral 1 by x into dx equals to integral 1 by p into dp. Then we know that integral 1 by x dx is log x equals to integral 1 by p dp is log p. Since both the terms in p, so we'll take integral constant as log c. Then log x equals to, we know that log a plus log b equals to log ab. From this we'll get log p plus log c equals to log cp or pc, whatever. Okay. And also we know that if log a equals to log b, then a equals to b. Okay, from this we'll get x equals to cp, then cp equals to x, then p equals to x by c. Okay, we got p equals to x by c. You can also write this as p equals to x into 1 by c. Since 1 by c is constant, so you can write this 1 by c as c. Then you'll get p equals to cx or xc. Okay. Now, you got this from the general solution using variable separable method, right? The general solution of this equation, right? Fine. Now what we'll do is, we'll simply substitute this p equals to cx, that is the solution, in the given differential equation 1. Okay. So consider the given differential equation, xp square minus 2yp plus x equals to 0. Now what we have to do? We have to substitute p. We'll replace p otherwise. Cx whole square, put p equals to cx minus 2y into cx plus x equals to 0. Then x into c square x square minus 2cyx plus x equals to 0. See, you're having x in all the three terms. So take x common from all these terms. You'll get x times c square x square minus 2cy plus 1 equals to 0. Then x becomes 0 and you'll get c square x square minus 2cy plus 1 equals to 0. See, this solution contains constant, arbitrary constant C, and it is obtained from general solution, right? So the solution is given by the second equation. Okay, this one, not this one. Fine. So this is a required solution of the given differential equation. This is a general solution to the given differential equation. Therefore, so this equation gives the required solution. Okay. Therefore, c square x square minus 2cy plus 1 equals to 0 is the general solution of 1. Is the general solution to the given differential equation otherwise. Okay. Otherwise, simply. So we have seen a problem from Solvable for Y in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.